You know, when you work with a Delta table, you see the data, you query it, and it just works. But have you ever stopped to wonder how? What gives it those superpowers? Well, it turns out, underneath the surface, there's this hidden, incredibly powerful component. A secret brain, really, that makes everything possible. And today, we're going to open it up and see exactly how it ticks. So let's start with a problem that I'm sure a lot of you have felt. You've got this massive data lake, right? It's filled with Parquet files, but honestly, it can feel like the Wild West. Queries fail out of nowhere, the data is inconsistent, and you just can't rely on it for anything critical. It's pure chaos. So, how do you tame something like that?
Well, it's actually pretty simple, conceptually at least. You give it a brain. And in the world of Delta Lake, that brain is a very special folder, one you've probably seen before, the _Delta log. This one little folder is the single source of truth that takes a messy pile of files and turns it into a reliable, intelligent, and trustworthy table. Okay, so let's start our dissection. We're going to peel back the layers and really get a look at the fundamental anatomy of every single Delta table. And you know what? It's probably simpler than you think, but this simple foundation is what makes all the really powerful features possible. So at its heart, a Delta table is just a folder with two main parts. First, you have your data files, which are usually in that familiar Parquet format. You can think of these as the muscle. They're doing the heavy lifting, just storing all your raw data. But the real magic, all the intelligence, lived inside that _Delta log folder. That's the brain we're talking about.
Let's zoom right into that brain. At its very core is something called a transaction journal. I want you to imagine a super meticulous, maybe a little obsessive accountant who writes down every single thing that ever happens. No detail is too small. That's exactly what we're looking at here.
So to be a little more formal about it, this is the transaction log. It is the absolute, definitive, chronological history of the table. Every single insert, every update, every delete, even a schema change. It's all recorded right here in the exact order that it happened. This isn't just some nice-to-have feature, it's the very foundation of Delta's reliability. So how does this journal actually work in practice? Well, every time you make a change to your table, any change at all, Delta creates a brand new, teeny-tiny JSON file in the log. Now, this file doesn't hold the actual data. Instead, it holds instructions. It says something like, okay, for this new version of the table, start reading this new Parquet file, and you can stop reading that old one. And this is so key. Nothing is ever truly overwritten. A new state of the table is just defined. Now, for every one of those JSON journal entries, there's a little companion, a CRC file. Think of it like this. If the JSON file tells the story of what happened in that transaction, the CRC file is its personal fact checker. It uses a checksum to make absolutely sure that the JSON file wasn't corrupted or only partially written. It's a small detail, but it's crucial for guaranteeing data integrity.
Okay, this all sounds great, right? We have this perfect, unbroken history of our table. But wait a minute. What happens when your table is really busy? You could easily end up with thousands, maybe even millions of these little JSON files. And if a query engine has to read every single one of them from the beginning of time just to figure out what the table looks like right now, well, that would be incredibly slow. And of course, the folks who created Delta Lake thought of this, and they have this really ingenious solution. It's officially called a checkpoints, but I like to think of it as the log's fast forward button. Or maybe it's executive summary. Here's the deal. By default, after every 10 transactions, so after every 10 new JSON files are written to the log, Delta Lake automatically performs a checkpoint. Now, you can change this number, but 10 is the standard, out-of-the-box setting. And what this checkpointing process does is actually really simple but so effective. It just takes all the information from those 10 individual JSON files and rolls it all up, consolidates it into a single super efficient Parquet file. So now, instead of reading 10 separate little stories, a query engine can just read one compact summary to get completely up to speed. This makes a huge difference for read performance. And to make things even easier, Delta keeps this tiny little file around called _last checkpoint. You can think of it like a bookmark. All it does is hold the name of the most recent checkpoint file. So a query engine never has to hunt around or guess. It just looks at this pointer, jumps straight to the latest summary, and then only reads the few new JSON files that have come in since. It's brilliant. So we've got the core brain figured out, right? It's a journal of JSON files with these handy checkpoint summaries. Now let's look at a few of the special chapters in this logbook.
some of the more advanced features that this whole architecture makes possible. First up, partitions. You know when you partition your data, maybe by year or by country, you're actually organizing your Parquet files into physical subfolders. But how does Delta know which folder to look in for your query? You guessed it, it's all tracked in the _delta_log. The log basically acts as a table of contents, telling the query engine, hey, you only need to read these specific folders. You can completely ignore the rest. This lets it skip over massive amounts of data. Next up, something really cool, deletion vectors. This is a clever performance hack. Imagine you need to delete just one row from a huge 1 GB Parquet file. The old way to do this was to rewrite the entire file minus that one row. Super inefficient. With deletion vectors, the log just points to a tiny little sidecar file that says, by the way, when you read this big file, just ignore row number 5. It's like editing with a footnote instead of a giant eraser. So much faster. And for those of you who are truly data obsessed, there's Change Data Capture, or CDC. If you turn this feature on, Delta will keep a whole separate log, usually in an _change data folder, that records the before and after picture for every single row that gets changed. This is incredibly powerful for things like auditing, debugging, or feeding data into downstream streaming systems. All right, so let's zoom back out for a second. We've dissected the brain, we've looked at its journal, its summaries, and some of its special chapters. But why does any of this really matter? Why is the log king? Because this simple, elegant design is the source of all of Delta's power. It's what enables ACID transactions, making sure your data is always in a consistent, reliable state. It's what unlocks time travel, letting you literally query past versions of your table. It's what guarantees data integrity with things like those CRC checks. And it's what ensures high performance with features like checkpoints and partition pruning. It all comes back to the log. So, if there's one thing to take away from all this, it's that the Delta log transforms your data from just a static pile of files into a living thing with a perfect memory. It keeps a perfect journal of everything that's ever happened to it. So, the only question left is, what will you add?